All right, everyone. So in this video, I am going to go over the different measures of central tendency that we're going to talk about in chapter 4. Dun, 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 dun. So means to an end, computing and understanding averages. Okay, so in this chapter, we're going to talk about what measures of central tendency are, and then the ways in which you compute them, so the mean, the median, and the mode, and then also when you would most likely use them. So this one video is going to be about the different types of measures of central tendency. So there are also different times in which you would use different measures of central tendency, and I'll discuss that in a different video. But first, let's talk about what measures of central tendency are. These are averages that best represent a set of scores. So in the social sciences and in the physical sciences, if we have a variable, this means that we have some characteristic that we're looking at that varies. So if we measured personality and we were looking at agreeableness, so how much a person agrees with another person or is easy to get along with, we can measure how much each person varies on agreeableness and assign a number associated with that, that characteristic of theirs that varies, and my level of agreeableness would be different from your level of agreeableness. And we can get big sample of 100 people and their levels of agreeableness, and then calculate the average of all of those things. So that's what a measure of central tendency is. And we have the mean, we have the median, and the mode. And so the mean is probably the most common measure of central tendency that we use, but it's not always necessarily the most appropriate. So we'll go over that, but first, when we're calculating a mean, we have this formula that we use here, and this is probably just conveying something you already know, how to calculate a mean, that is. So looking at that formula there, we have x bar. This refers to, that's how we annotate a mean. X bar, or it could be Y bar. If we're talking about a dependent variable, for example, we tend to use Y, and then we would do Y bar if we were looking at the mean of a dependent variable. So maybe agreeableness is our independent variable, and our dependent variable is number of friends or something. Okay, so then we have sigma here, this weird looking E thing, and this tells you that we're going to add whatever follows sigma. So usually when we have sigma, the thing that follows is a list of different values. So in our case, it's x, and x has it represents individual scores for a group. So the list that follows sigma in this formula here is a bunch of values of x. So I have one value of agreeableness after taking a personality test and getting a score. You have a value of agreeableness. Your friend has a different value, and so on and so forth. All these people, 100 people that we gathered data on, they all have different values of x here. So sigma is saying add up all of those different values of this variable. And then if we go back, we see n is the sample size. So that's how many people we measured in our sample. So in our case, our running example here, that's 100. So we would add up everybody's agreeableness scores. We could say the agreeableness scores out of 0 to 100 or 1 to 100. 1 is low agreeableness and 100 is very high agreeableness. And then we add up everybody's score. We average it by 100 people, which is how many people we gathered data on in our sample. Okay, so that is the mean. There you have it. And now when we're talking about inferential statistics, the lowercase n refers to the sample size, and then a uppercase n refers to a population size. We're usually gathering information about the sample size. We don't often have estimates of population size because that would be everybody in the whole group that we're interested in. Okay, sometimes we represent the mean using capital M too, so if you see that, that's what that means. Okay, Great, so that's the mean. But important to note here, this is a really key idea, that the mean is very sensitive to extreme scores that can skew or distort findings. So if we were looking at amount of time playing video games out of the year or something, maybe. We have maybe a lot of people clustering around a couple, I don't know, what's the normal amount of time to play video games? 40 hours or something a year? I don't know. Maybe, probably more than that, but let's just say it's 40. Maybe we have some extreme gamer person who is playing video games every waking hour, and that's a little bit of an outlier. That person could really skew a mean because he or she is way more extreme than the other people in our sample. So that if you have a really, really, really large score or really, really, really low score, that can skew your mean, and then a mean wouldn't be as appropriate. Then we would use a median. And I'll talk more about that as well. Okay, so the median is defined as the midpoint in a set of scores. It's the middle, right? Median is the middle. So it's the point at which half or 50% of the scores fall above and 50% of the scores fall below. So the person smack dab in the middle on a variable that we're interested in. And so if you were going to find the median, you would list all the values of your on your variable and your sample size in order from the lowest to the highest or highest to the lowest. So it doesn't matter which. But the point is that they're in order. And then you would go and you would count or figure out, if you had 100 people, you would find the 50th person, and that person would be the median. If you had two people that were if it was, I guess you would have to do 50 and 51 if you had 100 because it's an even number. And so you would take the average of 50 and 51. And then in R, I show you how to do this in our R code video. You can use short, and then I show some other R code that allows you to calculate the median, where you don't have to actually physically look at the middle score. It can just tell you by calculating what the median is because, R is a computer and it's smart and it can do all these fancy schmancy things for us that we don't have to do ourselves. That's the point of R, right? Okay. So, and then if there's two middle scores, then you would take the mean of those two middle values, like I said before. All right, and so then we already touched on this before, but why would you use the median instead of the mean? If you had the really extreme person who's really, really weird for some reason on your variable, then you want to use the median. It gives you a more accurate depiction because if you looked at income or net worth, for example, net worth is a classic example. If you got a sample of people and you ask them to tell you what their net worth is, and one of those people was Jeff Bezos, and you take the mean, then the net worth is going to be whatever ungodly, it's going to be really close to whatever ungodly amount of money that Jeff Bezos makes. Because he, has more money than like everybody else, all the rest of us put together or whatever. So if you take the mean, the average, it's going to skew very highly towards that extreme person. But if you just looked at the the person right smack dab in the middle, then you would get a more average or more true depiction of what average means in that data set. Okay, so then for the mode, this means this is the most often or the most frequently occurring value. I'm sure you remember learning mode, MO, most often, maybe in previous classes. So this is the least precise measure of central tendency, but you use it when you're looking at categorical types of variables. And we'll discuss more about that in the other video. So if you have these variables that are non-numeric and they're just these categories, like eye color, for example. That's not a number. You can't have an average eye color. You can't take up all the eye colors and add them together and take the average of that. That doesn't make any sense. So then you would look at what is the most frequently occurring eye color, and that will give you your mode. So depending on the kind of variable you have, you're going to use these different measures of central tendency. And I'm skipping past some of these details here, not because they're not important, but because I'm just giving you a brief overview in this video of a key concept here. Okay, so if you're going to find the mode, you would list all the values in the distribution, but list them only once, and then you tally the number of times each value occurs. And then you figure out which one occurs the most often. So you might look at a table like this where you see how many people say their political affiliation is Democrats, how many people say their political affiliation is Republicans, and then how many people say they are an independent, which is probably not 140. We're so politically divided now. It's probably more like 14. Maybe not for voter registration. In any case, that's how you would find the mode. You would say, oh, the most often political affiliation here is the independents. That's what we see the most often. And then I'll show you how to calculate this in R as well. So be sure to look at the R video that explains how you make these tables essentially like what we just saw here, but in R, so that it does it for you nice and easy. All right, so that's the brief overview of measures of central tendency. And then the next video, I'm just clicking around here, the next video will show you how the levels of measurement are associated with the different forms of measures of central tendency.